Welcome back. This is the last week of this course, week 12. We are done with all the technical topics that we need to look at. So week 12 is going to be a light week, a lot like week 1. We are going to see an overview of some of the pending topics that will be useful to know as a part of a course on software testing. So one such topic that I'm going to begin this lecture with is regression testing. Another topic that we will do this week is testing for quality parameters, otherwise what we call non-functional testing. Course in testing also has to deal with understanding of what are the metrics that are important for test engineers. So we will do a module on software metrics with specific focus on software quality metrics. Another important part is agile development methodologies, which you would have learned in the software engineering course, sorry. So agile development deals with a particular kind of testing called test-driven development. So I'll give you an overview of that. So this week is going to be miscellaneous topics like this. We will begin with regression testing. Here is an overview of what we are going to do in this module on regression testing. We begin with an introduction to what it is, highlight some important concepts, and then a lot of work in regression testing deals with test selection. That is, selection of which test cases to rerun. So we will see an overview of the test selection techniques. And I'll end by giving you information about some tools that are popularly used for regression testing. What is regression testing? We write software, a piece of code for a product, and we release that software. Post-release, it's not the end of software development. Software runs for a few years along with the customer at the customer sites and might have to be maintained. Maintenance can be of several kinds. There could be small errors that we find in the release software. If they are reported by our customers or stakeholders, the errors have to be fixed. A customer or stakeholder can also ask for new features in the software as add-ons to a software that is running. If we add a new feature, then that is also a part of maintenance. Sometimes they might ask for a particular feature to be replaced or removed with a particular feature to be removed and replaced with another feature. So removing a feature is also a part of maintenance activity. So maintenance is always done after release of the first version of software to create subsequent versions, which will involve changes in code that we make because there have been errors, because they wanted new features to be added or removed, and so on. So customers put in what we call change requests or feature requests. And there is an exclusive maintenance team which could overlap with the software development team which does this maintenance. Some software can last for several decades. We know of software that has lasted for 3-4 decades. So the maintenance activity for that software lasts much longer than the software development effort and involves serious kind of software development. Regression testing precisely comes in this phase. It's testing that is applied to test software in the maintenance phase. So in the maintenance phase, software is modified on and off based on need. So we have to test for the modifications that are done in the software, and we also have to test that the new modifications that we've done to the software don't alter or change the existing functionality of the software. So the process of doing this testing is called regression testing. So regression testing is the process of validating modified software with a few things in mind. We detect whether the modified software is error-free. Has it introduced new error just in the modified part or in the full software? And also that modified software doesn't introduce errors in the already existing correct working code. So these basically give confidence to the developers and the customers that the modified software is correct in the sense that all the requests for modification have been taken care of and the original code still works fine. So regression testing is typically done in a black box way. We don't open the code, new code with the old code and do a lot of white box testing. It's mainly a black box testing. As I told you, software lives sometimes for several decades after it's released. So regression testing is a well-used technique, and it's also expensive because based on the nature of your modifications, the problem of selecting test cases for regression testing can be difficult. So people end up retesting the entire software. In that sense, it can become expensive. So here is a simple example of how we will use regression testing. So let's say you have a software which is basically a website that you have developed, and the website accepts a lot of requests and has a search button. Initial release of the website involved a very simple plain text search button. You could involve text searches. Let's call that as a feature A. You release that along with the website software, and that involves giving a string or a word and searching for the word in the services of the website. So let's say you had tested this particular feature with 200 test cases, succeeded, and launched this feature. The software is running and is being maintained. So now there is a request for upgrading feature A, which is basically a plain text search feature, with adding regular expression like this. So you could add, you could search for a combination of words with operators like and, or, etc. So now you've developed this new feature B in response to the request, and you want to check whether this new feature B is working correctly. And so you have to regression test the new feature B and ensure that the new feature B, which involves combination searches, doesn't change any elementary part of feature A, which was involving a simple search. So now you have to decide feature A was tested with 200 test cases. Out of those 200 test cases, do I test it with all the test cases once again? Ideally not, because it gets expensive. So which of those 200 test cases do I reuse for testing feature A? And what are the new test cases that I could add or pick from these existing 200 test cases to test for feature B? So this is what we call regression testing. So this could come in several different kind of maintenance activities. So what is the process of regression testing? Let's say you have a procedure or software or a program. Let's call that P. So you make some modifications to P, and the new procedure or program or software, let it be P prime. P has been tested well, released. So you have a test suite for P. Let's call that T. So a typical regression test proceeds as follows. So we take T from P, and out of that T, we select a subset of test cases. Let's call it T prime. So those test cases T prime, we would like to execute it on P prime, which has P plus some modifications. So we test P prime with this selected subset T prime. And this will establish that P prime's feature are correct with reference to the extent that T prime has tested it. Based on what P prime is, many times in regression testing, we also create a new set of test cases. Let's call that T double prime. And those are exclusively for the modified software P prime. So we test P prime with T double prime and establish that P prime is correct to the extent that it was tested with T double prime. Now for the future use, we park or baseline a set of test cases carved out of T prime, T and T double prime. So, and then we keep it and say that the test software P prime was tested with a combination of these test cases, originally from the set T, from the modified set T prime, and from the newly created set T double prime. So that if you make further modifications, you could reuse them. So this is exactly what we do in regression testing. Now how to select T prime, how to select T double prime, how to create this merger of these three, there are various techniques available for it. And this is something that typically as a developer you learn on the job, but we will see an overview of some of those techniques. So each of the steps that we follow in regression testing has a process, and each step has a whole set of issues or problems that need to be solved. Step 1, which is this part, select T prime, which is a subset of T. How do you select that T prime, subset T prime? What would be the best way? Do you want to save or take a smallest subset T prime, Do you want to take a T prime that is effective in finding errors? How do you decide and how do you test? That is called regression test selection problem. The second one, which is step 3 here, creating a new set of test cases, is maybe you need a specific coverage criteria to be achieved on this modified software P prime. So you address this coverage identification problem. So which portions of P prime has to be tested for covering what? And why should I design, how should I design the new set of test cases T double prime? Now you want to test P prime with T prime, test P prime with T double prime. Steps 2 and 4 here. That will involve execution. So you can use a test automation tool. It could be JUnit. It could be any other regression testing tool. So you need an automation tool to execute that. Then finally, for further use in the future, step 5 says create a new subset T triple prime, which baselines a set of test cases from T prime and T double prime. So that is test suite maintenance problem. So for further modifications to P prime, how do I decide a base set of test cases? So the text that is colored in blue are the problems that you have to solve as you go on. Steps 2 and 4 are the easiest because if you have a good automation tool support, you can execute your test cases. But how do you select regression test cases? How do you add new test cases to it? And how do you park a set of test cases? Those are problems that need algorithmic or human intervention by a tester. So let's look at regression test selection problem. Before that, we have to understand some bit about regression testing versus specification. So regression test selection is applicable in 2 cases. Specification or your requirements have changed or they haven't changed. In the case where they have changed, we have to identify test cases from the original set T that are not useful for P prime, that are obsolete for P prime. So we say a test case T is obsolete for P prime if T specifies an input that is invalid for P prime with reference to the changed requirements, or with reference to the changed requirements again, T specifies an invalid input-output relation for P prime. So having identified such test cases and removing them, we can perform regression test selection on the remaining set of test cases. So selecting regression tests, what does it need? Obviously you need domain knowledge about the software that you're testing, how it affects the existing functionality. This is case by case based on the kind of application that you are dealing with. And maybe you could select test cases based on their effectiveness in finding a lot of defects. Maybe you could identify test cases on covering portions of the code that have undergone frequent changes. Maybe they were defective, they asked for a lot of features. For some reason, a particular part of the software has undergone frequent changes. So maybe you would like to test that. Maybe you would like to test based on the new critical features and the older critical features that you had. These are some of the sample criteria that you could apply to select regression test cases. What are the techniques that are available? Towards the end in my list of reference papers, I have given a link to a survey paper. These are just basically some material, a summary of what that survey paper for regression testing tells about. One is what we call minimization test selection techniques. So as the word indicates, the goal here is to select a minimal set of test cases. Maybe there's not too much time left for testing. So you select a minimal set of test cases that yield the coverage of modified portions of the original program P. In general, what is minimal? Is it number? Is it the time that it takes to execute? Or is it the reference to the coverage? We don't know. There could be several criteria. And we can't always guarantee that we will be able to find a minimal set of test cases. So it's in this sense that the problem in its generality is undecidable. But there are some techniques based on linear programming, integer programming, which are available for snippets of code which have single entry and single exit, like a basic block. And the survey paper that we have towards the end gives more details if any of you would like to know about it. But for now, just an overview is enough. The next is remember we saw data flow coverage criteria when we did graph-based testing. So there are regression testing techniques available on based on data flow coverage criteria. They basically exercise the data interactions, definitions and uses that have been modified in the process of getting P prime from P. So for example, a particular data flow technique recommends that every definition use pair that was deleted from P or is added newly in P prime be tested all over once again. So this technique basically selects every test case in T that when executed on P, exercise deleted or modified definition use pairs, or executed on a statement containing a modified predicate. Then there are a bag of techniques that focus on safety of the new modified version of P prime. So we call it safe techniques. Typical technique that is not safe will fail to select a test case that would have revealed a fault. So obviously it's not easy to come up with techniques that are always safe in terms of their guarantees to detect a fault. But whenever we have safety conditions that are specified as a part of the requirement, we can strive to get such cases. So when we are given an explicit set of safety requirements or conditions that has to be satisfied, regression test selection bases itself on those safety requirements and ensures that the newly selected set of test cases T prime contains all the test cases in the original suite that have the potential to reveal faults that can compromise the safety requirement in P prime. For example, you could do something like this. You take P and you take P prime and take the control flow graph of P and P prime. Even though we said it's predominantly black box technique, sometimes we can use the CFGs. We can add a test case T prime to the suite capital T prime for P prime if T prime when executed on P exercises at least one statement that has been deleted from P, or when executed on P prime will exercise at least one statement that is new to P prime. So this is one way of being safe generically without adhering to an explicit safety requirement. Then obviously you always have random testing. We write it down because it helps us to remember that when I'm completely lost in choosing test cases, I can choose test cases randomly. But most of the time it's just to tick off that you've done some regression testing. It's not considered a useful technique. Then there is the other extreme. You reuse all the test cases that you have and retest all. Again, this is not very effective because it's very, very expensive and typically you may not have time to reuse all the test cases. So basically there is this choice of regression test cases. These are two extremes. Retest everything, randomly choose a set of safe techniques, choose some techniques based on data flow, choose minimal set of test cases, generic test case selection techniques for regression testing. So it's up to us to choose what we want based on several factors: cost, customer needs, explicit requirements given by customer for regression testing, density of faults, whatever. So the choice is important. It has to be gained by experience because the effectiveness of regression testing is heavily dictated by how good you are in choosing the test cases for regression test selection. It's difficult to teach generically. A lot depends on the domain of use, the past sequence of defects, the added feature, several constraints that are specific to the application under test. So regression testing needs to be automated like all other testing. So typically choose a good tool and your job is usually done. And in the most of the cases, it's basically the tool that was used to test the original program itself, because you would be using the same setup. So you record the old test cases and replay it back using the same execution tool. But if you want to specifically focus on regression testing only, then here are some good tools that I have used. Remember, these are URL links, so they keep changing. That's why I've said that I've accessed them till as early as last week. But be aware of the fact that these URLs may not be intact all the time. So Cerebris testing is one good open source regression testing tool. So all of you as learners could try it out. TimeshiftX is another old tool which is proprietary, but it's been there for a long time. Test Sigma is another very good automation tool for regression testing. So there are a whole host of other tools. If you just search for them, you should be able to find them. This is just a selection that I thought I would tell you about. Especially one of them is an open source tool. So if you'd like to know more about theory parts of regression testing, I would recommend this survey paper. Otherwise, as I told you, many licensed tools exist, and you typically do regression testing as a part of your job when you maintain your software code. So I hope this overview on regression testing was useful for all of you. I'll stop here for now. Thank you.